So we can start where we left. So actually last time on the router 1 I missed this command segment routing MPLS. Due to that we were not seeing any output in the OSPF seed database. Because of this command because the configuration was incomplete, so that's why it was not generating any segment list for the R1 router. Since my lab has reset, so I have to complete the configuration again. I am almost done at the same level now. So let me just complete the configuration on the R1. So actually this command was missing. It's also missing in the instruction set for the router 1. So just take note when you are doing the configuration on R1. I have to change the seed number here. It will be 1. So you can see now it's showing the local seed, the node seed for the R1. If we check the show SPF seed database, earlier it was showing empty and there was no entry, and this L is showing like this is locally instantiated or locally originated, and showing the IP address and the number of seeds. So if we'll go to the other routers, so we'll try to verify on each router one by one. So here the moment we enabled on the router 1, you can see on R1 and R2. I will enable on R3 as well. Why I am doing this again? Because I forgot to save the lab and it just went to 0, so I have to complete the configuration again. We are just now doing the segment routing configuration, and we are able to see that the nodes, they are present in the OSPF using the segment routing. And if we will checking show MPLS forwarding, so we should be able to see the prefix seeds. So you can see here, actually the prefix seed is also called the node seed if its IP address is equal to the loopback address. So you can see 16001, this is for the node 1, 16002 for the node 2, and SR prefix seed and the index we can see. And at the bottom you can see the adjacency seeds, the links. For all the links it has also allocated the seed and the range, it's starting from the dynamic range. But for the node seeds, since we have specified the range from 16,000 to 2399, so it is allocating the label from the sRGB global block. So I will go to R4 and enable the segment routing configuration. Because of this range, it will use the labels from within the range. I need to change it to 3. Show MPLS forwarding. So I should be able to see the label for the other nodes. So you can see, I can see the 4 nodes, they are present within the seed database. So I will go to router 5 and go to router 6 as well. Meanwhile, it takes a little bit time to actually accept the configuration. So you can see the nodes. Now we have 5 nodes within the OSPF seed database. Let's go to R6 and we can see here after the configuration is applied, we should be able to see the 6th node. So all the nodes, they are present within the OSPF seed database. So next thing we can do is we can generate some traffic using the labels. So how we can generate the traffic? We can use the MPLS command and then specify the label that we want to use, the output interface and the next hop address. So then this command is actually will generate the traffic using this label, send the traffic over the specified interface to the next hop, and it will reach to the destination. And this is how we will be able to verify that the traffic we are generating, it is able to use the segment routing, and it is able to reach to the destination, so we can verify. So we can just take this example. In this case, we are going to generate the traffic for the label 16001, and let's see on which interface this router is. This is, I think, the router 6. If we go back to the topology, the IP address we have 10.3.5. so maybe this command is executed on router R5, but we can use any of the router. Just we need to specify the outgoing interface and the next hop IP address. So if I take the example of R6, if I use the output interface GI001, so what is the IP address that I have to use? The next hop will be 10.5.6.5, because from R6 this is the next hop. So let's go back to the router 6. So before that, I want to show you the MPLS forwarding, so you are able to see the labels. So you can see here I have 16001, and the next hop could be either 10.5.6.5 or 10.4.6.5. so towards the router 4, the IP address is, if I want to use towards the router 4, then I have to use the next hop 10.4.6.4. if I want to use the below path, then I have to set the next hop 10.4.6.4, and the same label is going to be used because we are using the same sRGB. So incoming and outgoing label is 16001. Even you can check the detail for the label. Show MPLS forwarding. If we type labels, then we can specify the label number 16001. So it will show us the detail for this label. If we just want to, if you want to see the more information, so you can give the command detail, and it will give you the information like about the label stack and the other information we also have. And maybe you have noticed it is showing us the number of packets that has been switched. That means how many packets had been sent using this label over this interface or this interface. So when we are going to generate the traffic, then we will observe the counters will change or not. So label, I want to generate the traffic for 16001, my output interface, if I want to use this in this route, so GI001, and next hop 10.3.5.3, but in my case it will be 10.5.6.5 because we are on the router 6, but maybe this example is for the router 5. 10.5.6.4. I think something was missing. Ping MPLS, next hop address. So we have to specify either this IP or the other IP. I will use the 10.5.6.5, and you can see it was successful. We can also take the trace route. As you can see here in the command showing, you can take a trace route, just replace the ping with the trace route, so then you will be able to see the different hops along the path as well. So we'll use the same command, just replace the first keyword. So instead of ping, we will say trace route, and now you can see it is showing us the traffic was sent out from this interface, which is the local interface on R6. So you can see it was GI001. This was the interface, and the local IP address, it was 10.5.6.6. So if we check the show IP interface brief, so you can see the 10.5.6.6. so this is the interface which was from where the traffic was generated. We said generate the traffic using label 16001. So it generated the traffic using the label 16001, and then next device has just swapped 16001, and it went to the last router, which would be this R3, and then it sent the traffic over this link, and the R1 has received the traffic over 10.1.3.1. So this traffic has hit on this interface and finally it reached to R1. So the difference with LDPs, our label is not changing, same, the label number is remaining same, but still the traffic is reaching to the destination. So this is different than the LDP as we were discussing during the presentation, the same thing. But now if I go to the MPLS forwarding table, show MPLS forwarding, so you can see I have the LDP labels as well and the segment routing label as well. So I have both of the labels. Like you can see there is 16,001, 16,003, 16,005 as well. So by default it will prefer the LDP. If I do not specify, like if I want to generate the traffic like traceroute MPLS IPv4, let me first execute this command again. So you can see the label is 16,001. If I am specifically specifying the label and trying to reach from R6 to R1. But if I do not specify the label and I just want to generate the MPLS traffic, so traceroute MPLS IPv4 172.16.1.1 32, but it is using the label which is not 16,000, it is using 24,800. So if we check the detail for this label, show MPLS forwarding labels and 24,008 detail. So we can see our local label is 8,000, outgoing label is 24,000, and yeah, we can see the other detail as well, MTU and this. But we remember in case of segment routing, we have specified the segment routing block which is 16,000 to 23,000. That means if we are seeing this label, this is not from the segment routing block. This is through the LDP. If I check the show run segment routing, so you can see here the label range we have specified for the other thing, but for the segment routing we have specified different range. I can include 16,000. So you can see under the OSPF, it is under the OSPF, not under the segment routing we have the range 16,000, 23,000. So if the packet is taking another label which is from the MPLS range, then it's from the LDP. So since we have verified like our label is working when we are using the 16,001, even the traffic is reaching to the R1. So in our network or in this environment, we can change the preference from LDP to segment routing, because by default LDP is preferred. So we have to give a command to prefer the segment routing. So let's see. Let me verify the command with what is it. So if you want to like prefer the segment routing over the LDP, then you have to go to the IGP and there you have to give this command segment routing SR prefer. So in case of ISIS you have to include MPLS keyword and then give the command SR preference, but in case of OSPF you have to go to the segment routing OSPF, segment routing MPLS, and then under that tell him that you need to prefer the segment routing instead of LDP. So we will go to the router OSPF 1. So if I do a route, so now check again, show MPLS forwarding. Okay, we already have the label, but if we generate the traffic for the 1.1, 17.1, so you can see now it's by default taking the label. Even I am not specifying, I am just generating the traffic for the 172.16.1.1, and then instead of using LDP, it's now using the segment routing. But if I go to any other router, like on the R1, there we have not specified the preference command, so that will keep on using the segment, the LDP, until unless we specify this command. So you can see here it's not taking the segment routing label range, it's using the LDP label range, which is beyond 23,900, because our range is our range is 16,000, 23,000 up to 2399, and if you see the route has beyond 2399, so this is not from the segment routing. So we have to change the preference and tell the router to use the segment routing as a preferred protocol for the MPLS forwarding. Okay, so I'm still facing some issue in R3, because when I'm trying to trace route, it's not using the segment routing, it's using the LDP. So let me see if everything is working fine in case of R3 or not. Show OSPF, seed database. So it's showing the local label, show MPLS forwarding. So I can see the label for the other router 125. 10.3.5.5 on R3, 10. What about the R3 on links? Even it's showing, but it's not showing the label for. So we'll see we have not done any mistake while assigning the prefix seed. So it's 16,003 here, and if we see in the OSPF database it's showing, but not in MPLS forwarding. So another way could be I can remove the LDP configuration and we just have the segment routing configuration. In real-time scenario you cannot do, because if you have customers you cannot remove the LDP until unless you have removed the issue with the segment routing. So I'm trying to apply again the configuration. So if there is anything missing, it could be fixed. So now you can see we have prefix it for 1, 2, 3, 4, 5, 6. Earlier it was not showing for these routers. 1, 2, 3. For 4 still it's not showing. 5 and 6 it's showing. So I will see on 4. Sorry, I'm on 4 and it's showing for the other routers. And if I go to R1, show MPLS forwarding, and now I can see 2, 3, 4, 5, 6. Earlier I was not able to see these. It was just showing 2 and maybe 3 as well. Since now we have, I can verify on the other routers, like on the 5 and 6, show MPLS. So it is showing 1, 2, 3, 4, 5, and itself is 6. For 6 it will not show an entry here, because it does not require a mapping to reach to itself. So I will now again take a trace route using the MPLS command, and now you can see it is using the label 16,000. and then next device is swapping the 16,000. So this was our desired result. Like we want to use the segment routing instead of LDP. Even we have LDP and segment routing both present in our network, but segment routing is getting the preference. So that means if you are in a network where you want to transition from the LDP towards the segment routing, first you need to enable the segment routing, then you need to verify it is working, and after that you can prefer the segment routing, still keep the LDP. So if there is any traffic which is going on based on LDP, it can go on, and once we have done the change this preference value, again verify the forwarding, and after that you can switch off the LDP. So then you do not need LDP anymore. But if you are doing traffic engineering, then for sure you will be using RSVP. So first you need to do the traffic engineering in the segment routing, and then you switch off the RSVP as well. So the idea of having the segment routing is to actually turn off two protocols, LDP and RSVP, because what LDP is doing, it's giving you the shortest path based on the labels, and the RSVP is giving you the capability to do the traffic engineering. So both of these things you can do using the segment routing. Segment routing itself is not a routing protocol. It's used the OSPF and ISIS to distribute the labels, and then it use the MPLS data plane to forward the traffic. And you can do the traffic engineering. So that means what you was doing using two other protocols, you can do using this single one as well. And it is, in this case, you do not maintain any state in your routers. Like there is no segment routing session. I only have here OSPF neighbors. Like I can show OSPF neighbor, but there is nothing like segment routing neighbors or any relationship they need to maintain for the segment routing. So that's why we say another thing like segment routing. In case of segment routing, the resources of your router you can save, and since segment routing will not have any kind of state, there will not be any relationship between the routers, so your resources will be saved, and maybe you can use for other purposes. So any question you have regarding this lab? Anyone who was following and he is able to complete it as well, can you please raise your hand? 1, 2. Anyone else? So do you want to have some time to do it? Okay, so now the time is -5, 2:37. So the break we have 30 minutes. So I think you can use this time. So I can help you if you need any help during this, and we can complete this lab, and then we can continue the presentation from tomorrow, because we have just I think 30 minutes, or we can use 40 minutes. We can use their break time because they are using our break time. Okay, so please complete the lab, then we will run the quiz. After that we can call the day off. Okay, you can do the lab, I can just prepare the quiz, and then we will run it. So meanwhile you can ask me or raise your hand if you have any question for the lab. So you have to type the answers. So in this case, let's see which is so these are the correct answers. Unfortunately, no one has typed it correctly. So actually the question was the dash determines the path a packet should take. So it could be the source node, it could be the source, it could be the source router. So in this case, source router is the segment routing starting, where from the segment routing is starting is the head end. Okay, so let's go on. So you see a diagram, and based on that you have to give your answer. So 8 people have been able to correctly identify. So it is P2, not P1. So we were showing the from diagram perspective from where the label was starting. So it was the P2 who was distributing the label to other routers. So this is our downstream and P1 becomes the upstream. So if the P1 start distributing the label, then it becomes the downstream and P2 becomes the upstream. Yeah, even I have told you answer in last explanation. Tail end. It was not the end router, it was tail end. So when all these terms regarding the MPLS domain, customer router does not has to do anything with it. So you need to think about the MPLS routers only. So it is the P2 with respect to this diagram. Okay, so again I was said earlier C1, C2, nothing to do with it. They cannot be an option. So the question was, what are the benefits of segment routing if we compare it with the RSVP? So scalability, flexibility, statefulness is not, because it's not stateful. Okay, we are halfway. A prefix id is type of SR identifier for individual adjacencies. Yes or no? Okay, it is false. Why? Because we are talking about prefix id, which is equal to node id, or the for the prefix attached to the node, and adjacencies, it is not the individual or adjacency seeds, because this is equivalent to the node seed. Okay, most of you got it right. It's the global segment, because all the router can recognize it, and they can like take some action regarding the instruction if there is any instruction related to this. So this is the equivalent of the node segment or node seeds, and we use the sRGB to identify them, to configure them. Okay, second last question. The segment that is used by the receiving router to process the packet. Okay, so these are the correct answers, or if you have typed this, then it would be correct. So what we are saying here, the segment that is used by the receiving router to process the packet, it would be the top segment or active segment or the current segment or the top label. Remember when we were doing the traffic forwarding, we were always processing 102 when it reaches to P2. And when it was reaching to P5, like 105, it should be the top label or top segment or the active segment. Because whatever is down, router cannot process it unless another router process the top segment and bring it as a top after it has processed. Okay, Usman and Atif. So you have last chance to. Okay, so the question was signals that the currently active segment is not yet complete and needs to remain active. So which operation actually we were talking about? So it was the continue operation. Okay, let's see who is the winner. Usman, Ramzan and Atif. Sorry? Okay, sorry, one question still we have. So at least I can say almost 90% people. So who is Usman? Okay, hope you see you tomorrow.